Hello, my good people. Welcome to today's math class where we have 25 to the power of x plus 4 to the power of x equal to 10 times 10 all to the power of x. What is the value of x in this challenge? It is easy, okay? So let's take our solution. Doing the first thing, so we have your solution. All right, all we just have to look at here is that this 25 is a perfect square and 4 is a perfect square. So we can rewrite 25 as 5 to the power of 2 and 4 as 2 to the power of 2. So this will now give us here 5 to the power of 2 close bracket out to the existing power, which is x, plus our 2 to the power of 2 close bracket out to the existing power. This is equals to 10 bracket 10 to the power of x close bracket. Now, what we observe here is simple, right? What we can do here, we can use this power to multiply this, use this power to multiply this. According to the law of indices, which says that you have your x all to the power of your m n, this is equals to your x to the power of your m bracket n, which is equals to your x to the power of your n bracket your m. With this, then we can now use this to multiply this. So this is going to give us here our 5, right, to the power of 2x, then plus our 2 to the power of 2x. This is equal to our 10, the bracket 10 to the power of x. All right. So the next thing we do here is easy. We want to eliminate this 10 to the power of x. So we have the 10 to the power of x. Equally divide this by 10 to the power of x. Divide this by 10 to the power of x here. So this leaves the system. So we are now having this power here as x like we did here. So no need even multiply this. So according to this, we can now rewrite this back in this format. So what we do here now is this. This can be written as our 5 to the power of 2 all over 10 all to the power of x plus our 2 to the power of 2 all over 10 all to the power of x. This is equal to 10. Is there anything common between this, and this? Yes. 5 can divide this and 2 can divide this, right? So if we use 5 to divide this, we are left with just 1 5. We use 5 to divide it to give us 2. So this is going to give us 5 all over 2, right? Then all to the power of our x plus here the same thing here. If we use our 2 to divide this, we are left with just one of the two, and we use 2 to divide 10, give us here 5, all raised to the power of x. This is equal to 10. Now, if you look at the tens in the bracket, the only difference is that this one, we have 5 at the numerator, we have 5 at the denominator. We have 2 at the denominator, we have 2 at the numerator. But we can switch this up and bring this down. What happens to this will take a minus sign. Remember, the law of indices which says that if you have your 1 all over your a to the power of n, this is equal to your a to the power of minus n, right? Good. So we can rewrite this middle term here. So if we do that, we're going to have here our 5 all over 2 all to the power of x plus our your 5 all over 2 close bracket all to the power of minus x. This is equal to 10. So we can bring in this one all and this division into the system. So this will now give us here our 5 all over 2 all to the power of x plus 1 all over 5 all over 2 all to the power of our positive x. This is equal to 10. So what we do next here is to do some simple substitution. So we can say here, let p be equal to 5 all over 2x. So if we do that, it's going to give us, wherever we see this expression, we put p there. So this now implies our p plus our 1 all over p equal to 10. This will give us our p to the power of 2 plus 1 equals to 10p. How? We have to multiply every term here by p. So we can now move this to this side to give us here p to the power of 2 minus our 10p plus 1 equal to 0. So this is a quadratic equation where we have to solve for two values of our p, right? So we want to use the quadratic formula to solve for this. So using the formula, method, so we're going to have our p here, right? We're going to have our p will now be equal to minus b plus minus the square root of b squared minus 4ac all over 2a. So what is our a here? Our a is the coefficient of our p squared and our b is the coefficient of our p here and our c is the constant term which is 1. So we can now put these values into our formula. So this now lies that our p will now be equal to minus bracket minus 10 close bracket the plus minus the square root of our minus 10 all to the power of 2 minus our 4 times 1 times sorry, what is our a? Our a is 1, yeah, times 1 and all over 2 times 1. So this is going to give us here 10 plus minus the square root of 100 minus 4 all over 2, right? Good. So if we subtract this from this, we're going to have 96. Yes, so we're going to have this to be our 10 plus minus the square root of 96 all over 2. Now 96 can be written as 16 times 6. So this is going to give us here our 10 plus minus the square root of 16 times 6. Yes, 16 is a perfect square, right? Good. So rewriting this will now give us 10 plus minus 4. The square root of 16 is 4. The root 6 all over 2. We can factor out 2 from here. So if we factor out 2, we're going to have here 2 into 10 will give us 5 plus minus 2 into 4 will give us 2, right? Then to the square root of 6 bracket everything all over 2 here. So 2 we cancel 2. So we're now left with our 5 plus minus 2 root 6. So these are the two roots, our x, 1 and 2, that will satisfy the substituted equation, this equation here. But here we have to recall that we don't have p in the original equation, so we now consider this expression here. Okay, so we now recall that we said let p be equal to our 5 all over 2 all to the power of x. All right, so this is p, please, not x. Okay, so from here we're not taking our case 1, so we have our case 1. All right, so our case 1, we said we have our p1 is equal to our 5 plus 2 root 6. From this our expression, we know that this is going to give us our 5 all over 2 all to the power of x. This is equal to our 5 plus 2 root 6, right? Good. So from here, we can get the value of x by simply taking the ln of both sides of the equation equals square use log to base 5 all over 2. But let's take a quicker way or quicker method to this. So let's ln both sides. So we have ln of 5 all over 2 all to the power of our x. This is equal to the ln of bracket open 5 plus 2 to root 6 close bracket. Right? Good. We are to consider one of the special law of logarithm, it says that if you have the ln of a to the power of b, and move this b to this side, this is going to give us here b times the ln of this a here. All right. So with that, we can move this exponent here now. This exponent, we can move it to this side. So this is going to give us here our x times the ln of bracket open 5 all over 2 close bracket. This is equal to the ln of bracket open 5 plus 2 root 6 close bracket. So from here, we're looking for x. So we just simply divide by ln bracket 5 of all over 2. Then we equally divide this by the ln of bracket open 5 all over 2. Okay, so from here, this leaves with this. So we now have our x equal to, we have the ln of bracket 5 plus 2, then root 6 close bracket, everything all over, then we have the ln of 5 all over 2. Again, we can rewrite this denominator according to the multiplication law of logarithm. It says that if you have your log m all over n, then this is equal to your log m and minus log n, right? So rewriting this is going to give us here our x will now be equal to, so we're taking this as our x1 equals to the ln of bracket open 5 plus 2 to the square root of 6 close bracket is all over the ln of bracket open 5 minus the ln of bracket open 2 close bracket. So this is our x1. Our x2 is going to give us a similar answer. The only difference is that this will take minus. So s2 is going to give us the ln of bracket 5 minus 2 to the square root of 6 close bracket all over ln of bracket 5 close bracket minus the ln of bracket 2 here. So these are the two values that will satisfy the original equation. So this brings us to the end of this math challenge here now. So if you learned something from tutorial, then give the video a thumbs up. Thanks for watching Math Prowess. To bring more solutions to you, so keep watching Math Prowess. Remember, we love you. Bye. Until we meet you in our next class.